In this video, I'll give a quick demonstration of how to solve a system of inequalities on the coordinate plane, and then show you a couple of possible different configurations of solutions that you could possibly have. We'll take this system here, 4x plus 2 is greater than or equal to y, and x plus y is less than or equal to 5. And what we want to do is we want to find the area on the plane that solves both of those inequalities. So let's take the first one. 4x plus 2 is greater than or equal to y. First, we plot the boundary. So this is, start at the y-intercept, which is 2. Use a slope of 4. And the line will look something like this. That's the boundary line. The boundary line is solid because this is greater than or equal to. Now let's take a look at x plus y is less than or equal to 5. For this one, the x and y intercepts are here. So there's y equals 5, x equals 5. And once again, this is a solid line because this is a less than or equal to inequality. And now we have to decide where to shade. So we'll start with 4x plus 2 is greater than or equal to y. We can test the origin, that's this point, in the inequality. So we can use 4 times 0, x is 0, plus 2 is greater than 0. That is true. So this point is part of the solution area. So we'll indicate that by shading this area down here. And then let's now look at this other one. X plus y is less than or equal to 5. If we use the origin as a test point in that one, x is 0, y is 0. Is that less than or equal to 5? Yes, it is. So the origin is also a part of the solution of this second line. I'm going to shade this in a different color. When I shade it, so shade it here. And you'll notice that there is this area down here where the two areas of shading overlap. So this overlap area down here is where the joint solution is. This is the solution area for the system. When you shade them by hand, what you'll want to do is you'll simply want to shade this area more darkly than you shade the other two areas. Now let's take a look at what happens when we have a system that has parallel lines. So the first system is going to be y is greater than or equal to is greater than 2x minus 4. So we can quickly plot that. Here's the y-intercept, and slope is 2. Looks like the boundary will go like that. And we'll plot the line, and it's a dashed line because this is a greater than inequality. And then let's plot the other line. Y is greater than 2x plus 1. Well, this line is going to be parallel to this line, except that it's going to go through this point. The y-intercept is going to be 1. And now let's see where to shade. So for the first one, y is greater than 2x minus 4. That's the lower line. We can test 0, 0 in here, and we get 0 is greater than negative 4. That's correct. So we're going to shade this side of the line. And then we can check y is greater than 2x plus 1. Once again, if we test the origin point, 0 is greater than 1. That's not true. So the origin is not part of the solution, and where we want to shade is going to be this area out here. So in this case, the solution to the system, well, first of all, it does have a solution, and second of all, the solution to the system is this whole area out here, up to but not including the line y equals 2x plus 1. Now let's take a look at this situation. This is really the same graph as before, and it's going to be y equals 2x plus 1, so that would be this line over here. And once again, it is dashed, so we'll leave it dashed. And then the other line is going to be, the boundary line is going to be y equals 2x minus 4, so that would be this line. But now let's check out which regions we shade. For y is less than 2x minus 4, that's the lower line, that would be this region over here. For y is greater than 2x plus 1, that would be this region here. And we'll notice in this case that there is no solution because the two regions do not overlap. So this is a case where there's no solution. Finally, I'd like to do a quick example where we have three inequalities together that we need to solve. So for this, we'll start by drawing x plus y is less than 12. So we'll go 2, 4, 6, 8, 10, 12 to here, and then 2, 4, 6, 8, 10, 12 to here. So that will be the boundary line for the first one. And since we want x plus y to be less than 12, 0 as a test point, 0 plus 0 is less than 12, so the area that we shade is going to be the area down here. And then we have two other inequalities. One of them is x is greater than 2, and that's going to look like this. And for that one, we're going to shade to the right, this line, because that's the area where x is greater than 2. And then we want to be x is less than 9. So here's 9. This would be the boundary line. And the area then, that is the solution area, is this entire area and extending down this way. So we have, and by rights, we should extend the boundary lines to the end of the graph so that we can see the full area. Extend this one down here, and extend this one down here. And then the solution area would be this entire area down here. And that ends this video.